Hi, and welcome to The Click. Today we're going to be covering word problems, and in this part 2, we'll actually be covering inequality word problems this time. So, how do you solve an inequality word problem? Solving word problems regarding inequalities are tricky because of identifying the inequality. By breaking down the question, we can derive the inequality and solve it. This is done similarly to how we've solved our word problems for linear equations, so you may notice some differences in how we exactly derive the equation based on the keywords there. So here's our first example word problem. 8 less than the product of 3 and a number is less than 13. Find the range of values for that number. So let's just focus on this first part of the word problem here. 8 less than a product is not what I'm going to focus on first, because that is something that's also going to follow after a number and its other relation with the variable that we have. So instead, I'm going to focus on the next part, product of -3 and a number. Now, let's say this number, we're going to represent it as x. This is the number, let's say. And this is as a product of -3 and x. Product will essentially mean multiplication, or the result of multiplication. So we can say minus 3x is our first part of the expression. Let's look back to our other part as well. 8 less than the product of -3 and the number. So since it's 8 less will usually imply subtraction. So we can say minus 3x minus 8. Now, 8 less than the product of -3 and a number is lesser than 13. So, this is our first sign of the inequality. We won't usually say that the result is 13 now because we don't have that kind of equation. We have an inequality now. So, we determine the inequality symbol through keywords like this, which are implying it. In this case, we have to use this one because the value of this is lesser than the value on the right-hand side, which is going to be 13. Find the range of values for that number. Now, to solve this, we can solve it like we had the previous week. We add the equation by 8 first, which will cancel out this minus 8 here. This will give minus 3x, and 13 plus 8. This will give minus 3x, and 21 over here, because 13 plus 8 is 21. Now with that, we can divide the equation by minus 3. We know that if we divide an inequality by a negative number, we have to flip this sign as well. So this minus 3 will get cancelled, the sign will be flipped, and it'll become 21 divided by minus 3. This will give x is greater than minus 7. Right now, I won't be representing these things on a number line, but you can also do that as an extra part of your work if you wish. However, this is the range of values that the number could be. Here's the next question. When 3 is subtracted from 6 times a certain number, the result is more than 75. What is the range of values for this number? So similar to the previous question, I'm going to ignore this first part, and instead I'm going to focus on the second part where it says 6 times a certain number. So since it says 6 times, I'll be writing 6x, where x is the certain number here, and only now will I be looking back to this first part. When 3 is subtracted from 6 times a certain number, because it says subtracted over here, I'll be subtracting 3 from the smaller expression of 6x. The result of this is more than 75. So I will be writing this more than symbol here because the value of the left-hand side is greater than that of the right-hand side, and the right-hand side is 75. What is the range of values for this number? Now, to solve this, we need to just add 3 to both sides, which will cancel out this negative 3 here. This will give 7x is greater than 78. Now, over here, this is a fraction that won't be able to be solved so easily. We need to divide it by 6, which will give x is greater than 78 divided by 6. This is a fraction that is not going to be able to be simplified so easily, but we can divide both of them by 2. This will give, and we can do the long division for this. So we add 3 over here. This will give 1 over here as a remnant, because 2 into 3 is 6. Now we'll leave 7 minus 6 is 1, so we leave that 1 over there. And then we get 39. So because of that, we'll get 39, and 6 divided by 2 is just 3, so we will get that over there. Then 39 divided by 3. This is actually a fraction that we can solve, since 39 is divisible by 3. This will just be equal to 13, so x is greater than 13. Here's our next question, though this is an age question. Lee is y years old. Toby is 8 years younger than Lee. The sum of their ages is less than 41. Find the oldest age Lee can be. So Lee is y years old. Let's focus on that first part. Lee is y years old. Toby is 8 years younger than Lee. This means that Toby is y minus 8 younger than Lee. The sum of their ages is less than 41. So y plus y minus 8 is less than 41. We can simplify this now. Y plus y, this is 2y, minus 8 is less than 41. Then we can add both sides with 8. 2y, this will cancel out the minus 8 here, and give 41 plus 8, which is 49. Now this can be divided by 2 on both sides. This will give y is less than 49 divided by 2. Let's see. There's no mistake being made here, so this is the final answer of 49 divided by 2. However, since we're working with the fraction here, I'm going to make this into a decimal so we can get a better idea. This will be 2 over here, and over here, when we're dividing 9 by 2, we need to take 8 instead, so we'll say 24. We'll add this decimal point here. There will be 1 difference here, and then this will be 24.5. So y has to be less than 24.5. Now the oldest age Lee can be has to be less than 24.5, and the only slightly lesser integer value of 24.5 is 24. Hence, the oldest age Lee can be is the age of 24. Here's one of the last few questions. The length of a rectangle is 4 centimeters longer than the width. So, similar to how it was discussed in the last video, the perimeter is essentially where we are adding all of the lengths and widths of the sides. The perimeter formula is 2L plus 2W, or you can write it as P is equal to 2 into L plus W whole, where the sum of length and width are in a bracket. The length of a rectangle is 4 centimeters longer than the width. So let's say that the width is equal to x and the length is equal to x plus 4, because over here we're seeing that the length of the rectangle is 4 centimeters longer than the width. Since it's longer, it has to be 4 centimeters more than the width. The perimeter is no more than 28 centimeters. That means that 28 centimeters is the maximum value, and that 2L plus 2W has to be no more than 28 centimeters. This means that the highest value it can be is 20 centimeters, but then it has to go down, meaning that the less than equal to symbol is the most appropriate for this specific equation. We can substitute our values of L and W over here, where L is x plus 4 and W is x. This gives us our equation of 2x plus 4 whole plus 2x is less than equal to 28. What are the maximum possible dimensions for the rectangle? So for this, I'm going to simplify this bracket first by multiplying 2 into each term inside the bracket. This will give 2x plus 8 plus 2x is less than equal to 28. Sorry about that. Now, 2x plus 2x, that is just equal to 4x, plus 8 is less than equal to 28. We can subtract 8 from this whole equation, which will cancel out this positive 8 here. That will give 4x is less than equal to 20, because 28 minus 8 is 20. We can divide the whole equation by 4 after this, which will give x is less than equal to 5, because 20 divided by 4 is 5. Now, this is the maximum possible dimension for the width specifically, because 5 is the most value that the width can be. Hence, if we're running by that assumption, we can also find the length through the similar way. The maximum possible value of the width is 5, so the maximum possible value of the length must be 5 plus 4, where we substitute this value of x from over here. This means that the width can be 9. So the width is 5 centimeter. Remember to always add the unit over here. And the length is 9 centimeter. These are our final answers. Sarah goes to Fredonia University. She has $900 in her savings account. She needs to buy a small laptop computer before the next semester. The laptop costs $600. Every 2 weeks, she withdraws $60 from her savings account for food. How many times can Sarah withdraw money for food? Write an inequality to explain. So, since Sarah is going to Fredonia University, this is one aspect that we can look at later. This is not very relevant to the question. She has $900 in her savings, so this is the most amount she can spend. She needs to buy a small laptop computer before the next semester. The laptop costs $600. Every 2 weeks, she withdraws $60 from her savings for food. How many times can Sarah withdraw money for food? Write an inequality to explain. So let's say the times that Sarah can withdraw money for food is X. The laptop costs $600 and it's a need, so it's not as if she can choose not to buy it. She has to buy it. And every 2 weeks she withdraws the money for food. $60 for food. So let's look at this a little bit better. I'm going to start with this time over here, or the amount of times that Sarah can withdraw money for food. She will withdraw $60 every time. So this will be involved in her expense. 60 into how many times she will withdraw from food, and this will come out of the $900 in total. If it's once, it'll just be 60. If it's 2 times, it'll be 120, and then so on. Our next step is to look at the laptop cost. We need this laptop. It is a necessity. So we have to keep this in mind, that it will be a part of the total cost or our total spending. This whole thing is an expression for our total spending, so 600 will be added to that expression over here. Now, this has to be lesser than equal to 900, because $900 is the maximum amount that we can actually spend, or that Sarah can actually spend. Now, this question is a little bit long and a little bit lengthy, so it does take a few reads to really understand it appropriately. However, after that, it is a little bit easier to understand. With that, let's solve the question. We can start by subtracting 600 from both sides, which will cancel out the 600 here. This will give 60x is lesser than equal to 900 minus 600, which is 300. Then x is less than 300 divided by 60, because if we divide both sides by 60, which will cancel out the 60 over here, this will give 300 divided by 60. Then the final answer becomes x is less than equal to 50, because these zeros cancel out. Then 30 divided by 6 is 5 actually, not 50, my bad. So she can get money, she can withdraw money every 2 weeks, only 5 times at most before she runs out of money to um, be able to afford all of these things. And with that, we're done. Here are the sources.